one? Well, what we're going to do tonight is we're going to go over a little, we're going to put together what we've been working on all week. And we talked yesterday about series circuits. And series circuits. And this, in fact, is Kirchhoff's law. Kirchhoff, C-I-R-C-H-H-O-F-F. Kirchhoff's law. And who is that named after?
Kirchhoff.
You guys, man, no!
It's named after Hank.
Dr. Hank Law. All right, Kirchhoff's law. And Kirchhoff's law talks about E total equals E of 1 plus E of 2 plus E of 3. We talked about this yesterday. And I total in a series circuit equals I of 1. Oops. Do it right. Equals I of 2, which equals I of 3. Which is to say that the sum of the voltage drops in any circuit. So if I have three resistors, the sum of the voltage drops, which means if I put a voltmeter across here, and across here, whatever those three read total together is going to equal this one here. So if I have a 6-volt battery, the voltage here plus the voltage here plus the voltage here are going to add up to 6 volts. And the current flow in a series circuit, that's a T, the current flow, if I have an ammeter here, that ammeter will read the same here and here and here and here and here. So that means that the current throughout the entire circuit is the same because it's flow. So whatever's flowing here has to flow all the way through and come back around. So when I measure flow in this pipe, it's the same all the way around in a series circuit. And resistance, which is futile, is R1 plus R2 plus R3. So our total is equal to, so the resistance of this one plus the resistance of this one plus the resistance of that one equals the total resistance. And then we talked about the fact that, well, of course, we talked about E, I, and R, which is whose law? Ohm's law. Ohm's law. Okay. And we talked about that. And I said, really, when you're solving these circuit problems, if you know two things, you can always find the third thing. All right. So given that, let's see here. See if I can find some examples. And these, so you have to do kind of a lot of the solving circuits here for your FA tests and stuff. So let's sort of emulate that. And of course, you can have a lot of different combinations of circuits, but we'll just kind of stick with about 3 resistors. And if I have, and this is how I like it, EIR, 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 and EIR. And I'm going to say, I'll use blue right here. So if I said that this is 24 volts, and this is 15 volts, and this is 0.5 amps, and this can be 8 ohms. Now, this is pretty difficult. I just want to see, it's actually not, it's quite easy once you know the pattern. Can you solve something like this and fill out everything for E, I, and R for each one of these? Okay, I know you can, but let's work this one together as a class. So what is the first thing that you want to do? Do you have a question or helping me? The answer. He has an answer.
Yeah.
Go for it, Toby.
I is and that stays the same.
Okay, Toby is correct. So when I look at this, I don't know if there's much else I could do except for one thing. I think he found the one thing. I look at this. The amps are the same through the whole circuit. I'm going to put it in red. Our answer is now in red. So I know that how many amps are right here? 0.5 amps. How many amps are here?
0.5.
And what is the total amperage? 0.5. All right.
You lost it for a second. How did you come to 0.5 amps on the 15 volt?
Okay, blue is given. I left everything in blue as a given. So if I know that my current flow through, we'll say this is R2, current flow through R2 happens to be half an amp, in a series circuit, what is the current flow through the circuit? According to Kirchhoff's law, I total is equal to the current through 1, or the current through 2, or the current through 3, on and on and on. So the current here is the same through the whole circuit.
Right.
Okay, therefore, the current is half an amp here. It's half an amp here, half an amp there, and it's also half of an amp here, right? What can I do now? Now it's wide open. There's a lot of things we can do. Go ahead.
Now you can solve for E for this voltage right here.
I should label these so this can be R1, this is R2, and this will be R3. So I can solve for what?
You can solve for resistor R2 voltage.
Okay, I can solve resistor R2 voltage. I could solve that. I could solve this. I could solve this, and I can solve that. You know, any one of those three things. Well, since you wanted to do what, R2? No, I can't solve for this. I'm sorry. I take that back. I cannot solve for this because I only have one thing.
R3.
R3. Okay, you want to solve for R3? Okay,
Can I do it?
you can do it.
I come up to the board?
All right.
Looking out for that stop sign.
Oh, he's going to write on my board here. Okay, go ahead.
Alright,
You don't know how anal I am about the boards. I wipe them down with soap and water all the time, and I have special wipes and stuff, and people touch them and I.
But go ahead.
It's all right. You kind of ruined my day, but go ahead. And you're not on camera. Camera reaches about here. All right. And by the way, of all my years of teaching, he's the first one who's actually volunteered to come up to a board and not turned around halfway. And once you turn around and look at it, it's like, what?
25 times 8. I don't know calculate.
It's 4.
Okay.
4.
40. Okay.
Guys got to help him out, though.
4.
4. All right. 0.5 times 8 is 4. So
E equals 4.
all right, right here. So it is 4 volt. Excellent job.
Yay!
Well, what else can I do? We can do this one right here, right? Let's do that. So R is E divided by I. So 15 divided by 0.5. 15 divided by 0.5 equals 30 ohms. All right, 30 ohms. All right, I could solve for this right here. Same thing. I want R, so E divided by I. 24 divided by half should be 48 ohms. All right, but now I got this over here. I got a problem. I still have only got 2 out of 3 things. So how can I get one of these others? Well, there's multiple things we can do. One, I can solve for E because E is simply going to be 24 minus 15 minus 4, whatever's left over has got to be that, right? Because this plus this, 1 plus 2 plus 3, R1 plus R2 plus R3 has to equal 24. So 24 minus the 15 and minus the 4 is going to equal 5. Okay, so 15 plus 5 plus 4, 15 and 5 is 20 plus 4.
R1 is 7.5.
R is 10.
E divided by I.
Is adding for the
Or
total?
divided by
Okay, now I can solve this in 2 different ways. One, I can either just do the math, 5 divided by 0.5, which would be 10, or I could have said, I got 48 over here, and I've got 38 over here, so 30 plus 8 is 38. I need 10 more, so my 10 is right there. Now, in fact, this is how I check you guys. So when you do something like this, you should also check yourself. And the way I check you is I just look at this and go I do the math. I go 30, 10, 8, because usually the resistors are given. And I go, okay, that's 48. Voltage here is usually given, so I do the math. I go 0.5, 0.5, 0.5, 0.5. Then I add these up. 15, 5, 4, that should be 24. He's got 24, and I'm done. Now if I want to add power into here, what is my power? Pi. P equals I times E. So power is 24 times 0.5 12 watts. That's not hard, is it? Okay, everybody should be able to. Now, again, you got to get to know me. If I'm talking about something and you don't understand it, now is not the time to go, hope that doesn't come up.
Right, yeah, I'm still having a little struggle. For some reason, I'm not making the connection. I understand the givens. I just haven't realized how you found the second.
Well, let's do another one.
That's all we did.
Let's see what I got here.
I have a question.
Yes, it's a question.
So why is the amps all just came across? Because when I was doing my diagram,
Uh-huh.
and I was doing the like E divided by R to get my I,
Yeah?
like each one's different
In series or parallel?
series.
Nope. The amperage has to be the same in series. Electron starts here and moves the next one, move the next one. They just flow through and it never changes.
Okay.
It has to be. Otherwise, you've done a math error.
Okay.
Because in reality, when you hook up an ammeter right here, and you hook one up right here, and you hook one up here, they're all going to read the same. They just do.
Okay.
And even if you have resistance in the wires, those things will know it. It'll drop it down for everybody. So what's one thing? What changes is that sometimes these voltages don't always add up correctly. And the reason why is because there's other voltage loss somewhere else in the wires. But in theory, it works. But in actuality, amps are the same. All right, so let's try it again. New piece of paper, one. All right, so we'll get one here. One here. Ooh, this one's got 4. So E-I-R, E-I-R. All right, so what are we going to give here? We'll give 24 volts as the given. Voltage, I will do R1 at 30 ohms. I will do R2 as 9 ohms. This time I'll just give you ohms. We'll do this one at 8 ohms and this one at 1 ohm. And you should be able to solve that. That's an easy one. Okay, so first we add up all the what? Resistance. Ohms resistance. Okay, so what do we get?
48.
48. So we got 30 plus 9, 39, 40, 48. 48. And don't forget to put the ohms, otherwise it's wrong. 48 ohms. So what is my current? Total.
E divided by R, so 20.
I'll put this here. E-I-R. So it's, I want I, so it's E divided by R. 24 divided by 48.
0.5.
0.5 amps. So here we go, Rich. If I've got 0.5 amps total through the circuit,
Mm-hmm.
how much is right here?
0.5,
0.5 amps. How much is here?
5,
0.5 amps. How much is here?
same,
0.5 amps. How much is here?
same.
0.5 amps. Now it becomes real easy. Just do the math on each one of these up.
Yeah, that one I understood easy,
Yeah.
because that's how I got my calculation. I just didn't understand when you started with 24 volts and you placed first the volts, then the current, and then the,
Oh, because in the last one of the givens, I just gave a given over here of 0.5 amps.
right.
And that's all I gave you. So you just have to know that that
So
is equal to that,
so
and that,
would
and
be
that, and
dropped
that.
back up again. Okay,
Yeah.
so that automatically gave 0.5 on everything.
Okay, so how many? What's my voltage drop here? I times R, 30 times a half, 15 volts. 4.5 volts, 9 times a half, 8 times a half, 4 volts, 1 times a half, 0.5 volts. Am I right? Yes, 15 plus 4 is 19 and a half, 19, 19 plus 5. Oops. So there we go, 24, and 5 across, and so that looks pretty good. So no problem there. Try to give you a hard one. Let me see. I think they're all too easy. Let's try this one.
gonna give us, one that's, where we have to find, power.
Where you have to find. I don't ever give you anything with power for some reason. I think the FA doesn't do it, so I don't do it. So
But it does it in our lab.
not where it gives you only power and then you work backwards.
Oh, right.
Yeah. So no, I don't. I don't have anything where it just gives you a power and you work backwards. Suppose I could, but I'm not gonna start now. All right, so we'll do 12 volts. 12 volts. Let's see if I can make this a little more difficult. 3 volts. 1.5 amps. This example only has 3, so we'll leave it at that. So 3, and then we'll make this 4. 4 ohms. There we go. Can you solve that?
Okay, so right off the back,
Well, you had your turn. Tell you what, you solve it. I'll give you a minute to solve it. Somebody's gonna hum some Jeopardy music.
Now that's track.
So as I walk around, I gotta wonder, how come I don't see calculators out? Charisse with 6 minuses on hers.
6 minuses.
Minus.
Oh, sorry, that's.
It's her hands on her calculator, just going crazy. She should know it. Well, that's about all the time you need, right?
Yeah.
Yeah. You thought that was so funny.
So in aircraft, I told you I worked for a guy I really liked, and he always stressed that accuracy first, speed comes with experience. So always strive for perfection and accuracy, regardless of the time. He would never say that word. But afterwards, it's all units of experience. The more experience you get, the faster you move. Only because you start to figure out where you can eliminate steps that were unnecessary, like 3 trips to your toolbox. Okay, you ready to do it? Wait. Yes. What, you ready? Okay. Should I just work it silently and you can not look up while I do it? No, because I want you to know what I'm doing. Okay, here we go.
Hold on a sec, the old guy's still moving.
We gotta wait for old guys, man. We're all gonna
Go.
go. Okay, what's first thing I'm gonna do? Amps everywhere. 1.5 amps. 1.5 amps. Oops. 1.5 amps. Now what?
You forgot one.
No, there's nothing here. There's no resistor. Total resistance is what? 8. Oh, I hope you're right. 8 ohms. Now what? R1. I can do R1 with 2 ohms. And I can solve for this, right? 6 ohms. 6 volts. Okay, now I'm left with this, which I can solve in a multitude of ways. One, I could do 6 plus 3 is 9 minus 12, which would be 3. Or I could do it the other way. I got 4 and 2. How many ohms do I have left over? 2. So 2 ohms right here. And E equals I times R. 1.5 times 2 is 3 volts.
So this was a tough one?
Yeah.
Oh, good.
Okay, the only way I can make it any tougher here, but I got to be careful because if if I make up stuff, the numbers have to match. I can't just throw in things in here. I don't have one here, so I gotta kind of think about it in my head or come up with something else. Let me see. Please stand by.
We just solved them all.
Hey, I gotta sign up.
Okay, so we could do something like this. I could say 12 volts. 12 volts. 12 milliamps. And what do you think? I don't want it to come out wrong. And so that would be, let me see, 750, 2,000, and we'll leave that open and see what happens.
2,000.
Oh, wait a minute, not 2,000. Sorry. I know, it's crazy. There we go. All right, should be able to solve that. And I don't know the answer, so. I'm just as excited to see it as you are.
Do you care if we convert the milliamps?
No. Is anybody completely lost right now? And like, I don't even know what to do.
So long.
Nothing's changed. Were you lost a minute ago?
No.
You got it a minute ago.
Yeah.
Okay, all I did is changed it to milli and added a K. Yes.
I just had a question.
I figured that's why you raised your hand. Well, it could have been wanted to tell us how much you likes us. Let's do that. No, okay. Go ahead.
For the total resistance, I'm getting 1,000 ohms. I don't think that would.
Okay, then I got a problem here. So that sometimes happens. My bad. I know. So we got it. That's a good point. See, I made up some stuff. I tried to do something in my head and it failed. So we got to change this number right here to something where this comes out. Oh, let's do this. I know. So hang on. Let's do this. Get rid of that because that was my problem. And I'm just going to do this. Now I know it's going to work out. 4K ohms. That I can see will somehow work out. Don't know how bad it'll be, but that wasn't a question. That was a comment. That was more like, "Hey, teach. That's jacked up, man." No wonder Sharice is lost. He's like, "Dude."
Giving her bad advice.
That's right. It could still work out bad, actually. I don't know. Hoping it won't. Yeah, it'll work out, won't it? Is anybody completely lost? All right.
Nobody answered yet, 'cause I wanna beat you guys.
Ready? You got it?
I nailed
You got it.
I'm just, I wanna go home and have a beer. Okay, not a health.
Yeah, speaking of that, don't you guys be coming to school stinking like alcohol the next day either?
On Tuesday.
Huh?
On Tuesday, you mean?
Yeah. Okay, here we go. So what's the first thing that I should do? What's the only thing that I can do that I can see? Well, there's two things I can do. I can either solve for the resistance here. I don't want it. I want to solve for what?
Solve for amperage.
Solve for amperage. Okay. Now the thing that I want you to know here is how you going to deal with this 4K? How are you dealing with that?
Just 4,000.
It's 4,000, but what are you doing? You converting it in your head?
Writing 12 by 4,000.
Let me try. Could I go up and solve it? I guessed what I got it right.
Well, hang on though. I got to talk to everybody. Make sure everybody's up. How you deal with this 4K? All right.
I guessed on the number.
This EE key right here is your friend. So it was how many K? Was it 12 volts and 4K? Okay, so if it's E, I, and R, you guys made Devin walk away. So E, I, and R, and it's E 12 divided by 4K. Are you converting that to 4,000 on your calculator? I'm not, because that's just one more area. So I'm going to put 12, 1, 2, divided by 4 second EE 3. So try that. 4 divided by, oops, I'm not 4.
Yeah, I got the same answer.
Well, you're going to get the same answer.
Oh, okay.
12 divided by 4 second EE the 3. Now, probably we could all, without problem, say, we're used to 4K, 2K, how much that cost? That's 100K. We're used to the K as something that is normal for us. You have to get really good at these, what I want to call them, not prefixes, more like suffixes, because we're going to use them so often. And I see people do the craziest things in electricity. It's like they will convert them 6 different times to get to an answer. I'm like, dang. That's why you're off by 3 zeros every time you do something. So if you get used to this 4 second E3, and the answer looks like 4E3, that is 4 times 10 to the third. Okay, that's really going to matter when we start dealing with numbers like 6 milliamps. So how do you convert 6, and you're trying to run this in your head. So if I want to do 6 milliamps, it is 6 second, the EE key, then negative, this one down here, negative 3. And that is milli, the negative 3. So you don't have to convert it in your head or on another piece of paper or multiply it. Because if you're out there going 4 times, because you guys are doing this already with the Simpson meters. It's like the answer, I look at it right there. It's like you got it on a 100 scale, and all you have to do is add a 0, and you're like, okay, you do this, and multiply that, and divide by 6, and then add 32. And I'm like, what the heck? You come up with the right answer, but it's, takes you a while. So anyway, get used to that. Unless you don't want to, then no, I'm not going to make you. All right, so what is this right here, this answer?
0.003.
Well, you guys are mumbling. What?
0.003 amps.
I want that in milliamps now.
3 milliamps.
3 milliamps. All right, so and I got 3 milliamps there, 3 milliamps there, 3 milliamps there. All right, now what?
If it says milliamps on the test, do you want it kept as milliamps?
Probably, yeah.
Make sure
I'm not going to mark it wrong, but
when I throw it
it'll
off.
just make me a little grumpy if I have to convert it from my answer key, and then from there on out, I'm just grumpy with you.
Yeah, but it's fine.
Actually, Callie's the grumpy one. So.
Please.
She takes that on me anyway. What's next?
Solve for the voltage of R1,
What is the voltage for R1?
2.25 volts.
Is he correct? How about this? 6 volts. And what do we got left over here? Well, same thing. I can either figure that out. What is it? 1,250? 1,250 ohms. And I got that because 4,000 minus 2,000 minus 750 equals 1,250. Or 1,250 plus 2 plus 750 equals 4. I hope all right. There we go. And then I solve for E. I can either do the math going up with Ohm's law, or I can just use Kirchhoff's law and say that 2.25 plus 6 plus this is equal to 12. What is my answer? 3 point what? 75 volts. All right. That's not hard, is it? Okay. That's as hard as I can really make something like this. It doesn't get any harder. You just have to, once you know these laws and these rules, you just plug in what you got. So the hardness part really, it just comes in with using things like milliamps and kilo. All right, you just got to get used to that, and I expect you to know milliamps and kilo.
So you won't get all, I'm saying, I'm used to doing it, I just make it put the zeros in first, you know what I'm saying?
Okay, if I put this in front of you and it's a test, and I had 3 milliamps, and you cross it out, and right next to it you put 0.003 amps, that works for you. Works for you. I've got no problem with that.
Okay.
I want you to get it right on the FAA tests, and so that's what I care about. That's what I want you to walk in these FAA tests and go, that was a joke. Is that all you got? And that's the people from this program. That's really what they're saying. That's all you got? Seriously? That's all you got? Bring it on. And they laugh at it. They laugh at the tests.
Phil told me not to make the FAA grumpy though.
Well, we're not going to tell them
Yeah,
that.
you don't actually say that.
Actually, the
Think
FAA,
it when you're walking
the
the
FAA
dog.
loves us. They think we have a great program. They back us. Okay, let's talk about parallel. But it is 8:20. You probably want a break.